Okay, so in this tutorial, we're just going to understand how we go about implicit differentiation. So what exactly is implicit differentiation? So I believe we know what differentiation is first of all. So if you've been given 2x squared plus 4x minus 2. So if they ask you to differentiate this in respect to x, all you're doing is you're assuming y is a subject. If y becomes a subject, then we are saying you're differentiating in respect to x dy dx. So you multiply the power by the coefficient and then reduce the power by a 1. So 1 times 4 will be a 4, 1 minus 1 will be a 0. So of course the derivative of a constant is a 0. So that is basically our result. Now in a case of implicit differentiation where actually trying to differentiate the implicit function. So what exactly is an implicit function? So if you look at the equation that I've written, this is implicit. Why? Because in this case, it is not possible for you to make y the subject of a formula. So it's very, very simple. So for example, if I can give you a normal function, an explicit function, where you have 2y minus 4x. If I ask you to differentiate this in respect to x, what are you going to do? You know it's possible for you to make y the subject, right? What do you do? So 2y is going to be 4x there, and then y becomes 2x. So now if you try to differentiate now, you'll find that the derivative of 2x is what? The answer is 2. Okay. Now, the idea of implicit differentiation is built on this very idea. So if you look at the 2y minus 4x, do you know what we can decide to differentiate it? I'll demonstrate how we go about the implicit differentiation. So we are trying to differentiate the entire equation in respect to x. Okay, so the moment you just differentiate something that has got nothing to do with x, you need to introduce dy dx. So y, for example, we'll differentiate it the normal way. Y is raised to the power 1 in that case. So 1 times 2 will be a 2, and then 1 minus 1. So as we said, the power reduces by 1. So you will notice that the y will basically go away. So you just remain with 2. Now because we are differentiating y, we'll put dy dx. Why? Because we are differentiating in respect to x, and there in this part there is no x, so put dy dx. And then minus 4x, the derivative of minus 4x is a minus 4 equal to 0. So the idea of implicit differentiation is you need to make dy dx a subject. So therefore, if you add 4 both sides, this negative and the positive one will go, and then divide by 2 both sides, this 2 will go away. So you end up with the same result as in making where we had made y the subject, right? The answer is still a 2. So with that understanding, we are now capable of simplifying the question that is on top implicitly. Okay, so if you look at the first part, we have x squared. So what is x squared? If you differentiate that, what's the derivative? It's 2x squared. It's 2x, sorry. The power reduces by a 1. And then y squared, the same. It will be 2y. The power reduces by 1. Now, we are differentiating in respect to x. So I'll put dy dx. And that is the only rule that you need to remember. Always add dy dx in a case where you differentiate a letter that is not of our interest. Okay. And then minus 4x. The derivative of minus 4x is what? Is negative 4. The derivative of 5y is what? Is 5. Now we've differentiated y, so put dy dx again. That is the only thing that you need to remember. Very important. The derivative of a constant is always a 0, so we just remain with a 0 on the right hand side. Now at this point, we need to maintain that items that are having y on the left hand side. So we have 2y dy dx, and then we also have plus 5 dy dx. So every other term would have to go the other side. So we are remaining with 2x and minus 4. So we have 4 minus 2x. So we'd have to now, if we look at our left hand side, we'd have to factorize out the dy dx since we want to make it the subject. So after we do that, we have dy dx. In the brackets, you have 2y plus 5. On the right hand side, you have 4 minus 2x. So we know what to do there. Our goal is to make dy dx a subject, right? So ultimately, we'd have to divide by this on both sides, so that you just remain with what? With it on the other side, so that it will be 2y plus 5. So what is our derivative of that implicit function? And that basically introduces the idea of implicit differentiation. Of course, just one more example to just help you understand one thing that is very necessary, very important in terms of the product rule, the way we tend to apply the product rule when we're dealing with implicit differentiation. Now, consider a situation where you have y squared and then multiplied by 2x. So in this case, how do you differentiate this implicitly? So the basic idea is this is now going to be considered to be a product rule. Okay, to be product rule. Product rule is the one that's going to apply. I can even add some more functions to just make it more interesting. Okay. So product rule tells us, demands us to consider first of all, if any term of your choice, I'll start with y squared, and then I'll multiply by the derivative of the other. So the derivative of 2x is a 2 plus. So in the first part, I considered y squared. Now I'll now consider 2x. I'll start with 2x. And then I'll multiply by the derivative of the other. So the derivative of the other is y squared in this case. So y squared, when you differentiate it, will be what? 2y. Now, the fact that we're differentiating y instead of x, we'd have to put dy dx. That is the only rule. Whenever you differentiate a term adding y, add dy dx. Okay, so everything else remains the same. The derivative of y squared is what? It's 2y. Now, because it's y, we're putting dy dx because we're differentiating with respect to x. The derivative of 2x is just a normal, it's a 2. Okay, so now at this point again, the same rules apply. You need to remain with what? The term having dy dx on the left hand side. So I'll expand this term. So you notice that 2x times 2y will be 4xy, and then we have a dy dx. The other term having dy dx is 2y dy dx. Everything else goes the other side. So we have this part to be negative 2y squared, and then the constant 2 also goes the other side. Okay, so at the point where we've reached now, all we can just do is the same procedure. Just factorize the dy dx, right, on the left hand side. So we have dy dx. What remains with 4xy for the first part, and the other part will remain with 2y. On the other side, we have negative 2y squared minus 1. So to make things easier, we'll divide by this both sides, so that we just remain with 4xy plus 2y. And that basically summarizes the idea of implicit differentiation. If you've understood whatever we've done, I believe you're okay. So make sure you subscribe to have access to more other videos related to math, chemistry, physics, and biology.